should probably record. Okay, so this is just for me.
Could you repeat the numbers you said?
Yeah, it's going to have an initial velocity of 0 meters per second. It's going to have an acceleration of 2 meters per second squared, and it's going to do that for a grand total of 20 seconds. So how far will it have gone after that period of time? Yeah. Don't hesitate to unmute yourself, guys, to ask a question. And then can you guys kind of read what I'm putting on the board? Or should I like kind of scoot the laptop a little bit closer?
Scoot it closer, please.
Okay, cool. This might be kind of annoying and loud. Okay, folks, does anyone have a potential answer yet they want to go and take a shot with? We got 400 meters from Braden. Okay. We have 4 meters from Jared. Okay, be interesting to see how that they came up with that. And then a couple more 400 meters. Okay, so in reality, the answer there is going to be 400 meters. Now, let's go ahead and talk through how that is. So with this formula, since our initial velocity is 0, 0 times 20 is 0. So we effectively have 0, and the acceleration here is going to be positive. So it's going to be plus 1/2 times 2 times 20 squared. Okay? So 1/2 times 2 is 1. And then 20 times 20 is going to be 400. So 1 times 400. We have 400 meters. Jared, when you look at that, do you kind of see where you maybe made a mistake, bud?
I put 2 for the time instead of 20. I thought you said 2.
Oh, no, that's okay. That's okay. Yeah, so that's an honest mistake. Okay. Now, we're going to do the same inputs. So 0 meters per second for the initial velocity, acceleration of 2 meters per second, and then time of 20 seconds. Now I want you guys to go ahead and tell me, how fast would it be going after those 20 seconds? So if we go back to the shared screen, notice, guys, the velocity, V equals the V sub O plus AT. So now, what is going to be that velocity after 20 seconds? Nice, we're getting a lot of 40 meters per second. Great job, guys. Exactly. Because we have 0 plus 2 times 20. So we're going to come up with 40 meters per second. All right. So now it's time to get a little bit trickier, okay? Because now we're going to start doing some projectile motion. Every time we talk about projectile motion, gravity is negative 9.81 meters per second squared in this class. Okay? It's always going to be negative 9.81 meters per second squared. So we're going to go ahead and we'll start off with a relatively easy one. If you take a baseball, you throw it straight up in the air, and its initial velocity is 15 meters per second, so it's just flying, okay? After 3 seconds, where will it be? After 3 seconds, where will it be? Okay, Braden came up with 0.9 meters from the ground. That could definitely be right. I haven't written a single thing on the board yet because I don't want to give you guys the answers. I want to make it urgent. There you go. You got 2 people that are in agreement. Anybody else with them? All right. So let's work our way through it. Initial velocity is 15, time is 3 seconds. 15 times 3 is going to be 45. Now, the acceleration here is negative because we're bringing ourselves down, so that's going to be a negative sign there. So we take 9.81 and we multiply that by 1/2. Now, half of 9.81 is going to be 4.905. And that's going to be multiplied by 3 squared, because it's 3 seconds, so t squared. So now we're going to have times 9. So 4.905 times 9 is going to be I mean, obviously, yeah, it's pretty close to 44.1. So it's going to be 0.9 meters off the ground. Nice job, guys. Good work. Does that make sense?
Dr. Lane, I have a question.
Yeah, what's up, Jared?
On that formula there where x is that plus x? Does it say x equals b naught t minus a half t squared plus x?
Yeah, so Jared, that's going to be in reference to where we're going. Okay, so now
Well, that's what I was going to ask. Technically, when you took that x over, you would have a 0x, right? So that would be an unsolvable problem.
No, because you're forgetting the context of the fact that this is going to be the x final. This is going to be an intercept of where we started.
I got you. Okay.
So the basic idea here now, and feel free, Jared, you can stay unmuted. Somebody else, feel free to unmute yourself. If you throw a ball vertically, where did that ball actually get released from?
The ground.
Did it?
Well, I mean,
I want you to take a video of yourself throwing a ball vertically.
well, I mean, me standing on the ground from my hand.
And so if your hand's on the ground, you're going to be taking a lot of skin off your knuckles there.
I said standing on the ground.
So where's the ball actually released from?
Your hand.
Height-wise?
The very top. I don't know what answer you're looking for here.
How far your hand's off the ground?
Oh, okay.
Does that make sense?
Yeah.
So most people are probably going to release that ball 1.5, and maybe if you're really tall and really long, like over 2 meters off the ground. So if you're releasing the ball from 2 meters off the ground, this x becomes 2. Does that make sense? So after that period of time, the ball is actually going to be, instead of that 0.9 meters, it would actually be that 2.9 if you release it at 2 meters off the ground.
Okay.
Okay?
Yeah.
Trying to start easy here, man. We're not trying to go straight down into the deep end, but if you want to swim, you can start.
No, I remember some of it from physics. We've done all this projectile motion and stuff. It's just been a while since I've done it.
Well, knock the rust off. It's time to get back in the trenches. So now we're going to do hard math. Okay? That was easy stuff. Now we move on to the hard stuff. Okay? At what time would that ball have hit the ground? At what time will the ball have hit the ground? And so, folks, now we go back to our formula page. And the key formula we need to use is here, is this quadratic formula. Because once we set this up, because we no longer have a t, that's what we're solving for. But we do know the x we're trying to solve for is 0, okay? Now notice how that is going to be our quadratic formula. So our a term to x squared is going to be that 4.905 times t squared. That's negative. Then we're going to be plus 15 meters per second times time. And then we have effectively a plus 0. So this becomes our A term, this becomes our B term, and this becomes our C term. So then our quadratic formula is going to be x, which in this case is 0, equals negative b plus or minus, because we're going to be able to run both of them, b squared minus 4ac over 2a. So now, guys, we're going to run, remember, these terms through this formula. And we're trying to figure out a way that we can solve this for 0. So work your way through it. Once you guys come up with an answer, go ahead and put that in the chat. And then I'm going to walk through it with you guys. How we doing, guys? Is anybody completely lost? They just want me to walk through this one for them?
Me.
That's okay.
Add me to the list.
No offense, guys, it's okay. It's not easy. It's some of this math you haven't seen for a long time. Some of it maybe you guys haven't seen, and that's okay. So, once again, we're going to start off with our initial formula. We're then going to organize the terms so that we understand that we've got our A term, which is going to be the negative 4.905 times t squared, plus then we have our B term, 15 times time, and then we have our C term, which is 0. Now, you have to remember the old school PIMDIS, so parentheses, blah, 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 multiplication, division, addition, subtraction, when you do your orders of operation. So first thing we're going to go ahead and do is start within the square root side of this formula. Now, the A term here, every time you see an A, that is 4.905. Every time you see a B, that's going to be 15. Okay? And then the C term, remember, is 0. So it actually does us a favor because I kind of set this thing up on easy mode for us, though it might not feel like it. Because we're going to have 4 times 4.905 times 0. And anything times 0 is 0. So effectively, this part here becomes minus 0. Okay? 15 squared is going to be, okay, 225. And then we take the square root of 225, which is going to be, anybody? Anybody?
15.
Yeah, 15. Good job, guys. So we have negative 15 plus or minus 15. So we get two different options of what we can get for our solution here. Now, one of those two options is going to be essentially 15 plus, or negative 15 plus 15. So we're going to have 0, which makes sense because the ball started on the ground at time 0. So that is one of the two answers. But we're looking for where it hits the ground after being tossed. So we want the second of the two answers. So now we're going to figure out, okay, so if you have negative 15 minus 15, what we're effectively going to have is negative 30. Now this is going to be over, and remember guys, this 4.905 is a negative term. Okay? So negative 4.905 times 2 is going to give us negative 9.81. So we have 30 divided by 9.81 is going to be our second answer for the time. So, yes, Jared? Okay, Jared. So now we're going to be able to just change these plus signs because a negative over a negative is positive. So we're going to have about 3 points. Yeah, it's really going to work itself out to only like, I think
3.06.
Say it louder, bud.
3.06.
3.06, awesome. Is that what everybody else is coming up with?
Yeah.
Awesome. Okay. Who's got questions?
Is there a way to find that without using the quadratic formula too? With using one of your first equations?
Yeah, I mean, you could do that. You could just keep plugging in different times until eventually you got the answer 0. But that's going to be pretty exhausting. And the others, you can obviously just graph it.
Okay.
Figure out, where you find the point where it intersects with 0. Okay. So now that we've gone through one of these, you guys ready to try another one? Okay, sounds good. Now, let's go ahead and, so I'm just kind of clearing out the parts I wrote on here, so it's not going to be confounding you guys as we're going through, but you can still see the formula, and I can still keep the share screen up so you guys can kind of see what's going on. Okay, so this is going to be a two-parter. Okay, two parts. First part is, at what point did this ball go to -2 meters? Okay, so what we're doing now is imagining that someone threw the ball, and as they're throwing the ball, it's obviously going to arc up and over, and then it's going to come back down. So if we're going to like think about drawing this out, it's going to look like this. We're trying to look for this point in time, where our x we're looking for is going to be -2, okay? But the first thing we got to figure out, the first thing we're going to figure out is at what time would it hit this -2, because what I want you guys to solve for is how far did the ball travel? And so what we're going to say is that our vertical velocity is going to be only 5 meters per second. Okay? Because then we're going to go and do this a second time, where all this is vertical data. We still need to find the time. We're then going to have the horizontal, where the horizontal velocity is going to equal, yeah, let's make it crazy fast. Let's make it real fast. 20 meters per second, where our acceleration is going to equal 0, because we're just going to imagine we threw this in a vacuum, yet still somehow on Earth. But we still need the time from this answer, because it'll be the same one, because we're trying to solve for x of how far it traveled. So, sorry, make sure you guys can see this. Give you guys a perspective here. This thing is maybe 2 feet long. The camera is maybe right now 3 feet from the wall, so I'm like trying to do everything pinned in here. And as you can tell, I'm super awkward. So, this is the first one we're going to solve for, guys. Where is our time? How long would this have been in the air for? Whenever you guys think you have the answer, go ahead and, oh, I need to plug that in. Anybody have a guess yet? Or should I say an answer? I feel like I should be playing the Jeopardy theme in the background or something. Somebody please say something. Okay. Caitlin, how you doing this morning? I appreciate that, Luke. Making sure the screen hadn't frozen. Good. You got a guess for me, Caitlin? All right, so let us start from the beginning, folks, for that is a great place to start. Sorry, I had a student asking a question, so putting on that mask. We follow the freaking protocol. All right, when in doubt, set it up. So you kind of see how I've drawn this out, where we have an initial velocity of 5 meters per second vertically, 20 meters horizontally, and we're trying to figure out effectively how far would it travel before it hits the ground, -2 meters from its starting point. Okay, so what does this mean? This means that we need to go ahead and use our happy quadratic formula over here, because we're trying to solve for time, which we don't have. However, now we have both a term, B term, and a C term. Okay? So the B term is going to be 5. The A term, because it's going to be that 1/2 of -9.81, so it's going to be -4.905. C term is going to be +2, because we're starting off the ground and then we're landing at a lower location. So now we're going to be plugging in 2 in that location. So things are a little more complicated. So now we've got 4.905 times 4 times 2. Sorry, that is negative. Okay? So that's going to give us 8, 16, 19.56. Is that what you guys come up with? Somebody go and give me a little help here. 4 times 4.905 times 2. Oh yeah, I did jack that up. Thank you. Okay, so now we're going to have over here minus 39.24. Okay, our b squared, so that's simply going to be 25. Okay, and since it was minus a negative number, we're going to plus it. So now we have the square root of 25 plus 39.24. Okay. Over here, if you guys want to go ahead and let me know what the square root of 25 plus 39.24 is, I would be very appreciative. Thereabouts 8.015. I like that, Luke. I like that. So we're going to have now 8.01, 8.015. And it's okay, guys, after 2 sig figs for what we're doing here. I'm not going to take off because you guys made a slight rounding error, as long as you're still in the ballpark of where you need to be. I will take off if it was more or less just like you're off by more than a tenth. Okay, and even if you're super close, you're still going to get most credit. I give partial credit on the math problems when they're not multiple choice. Okay, so negative 4.905 times 2, that's going to get us back to that 9.81. So now we have 2 potential answers here. We've got negative 5 plus 8.015. So we're going to have one potential answer is 3.015 over negative 9.81, which is going to give us just less than 0.3, just about 0.3 negative seconds. Now, what's the problem with negative 0.3 seconds?
It doesn't exist.
Oh, come on, John. Don't you wish you could just go back in time?
Very much so sometimes.
Shit, I don't know about you guys. I could definitely go for going back to late February. You might not miss the winter, but you sure do miss the being able to actually be near other humans. Or maybe that's just me. Okay, but you're absolutely correct. That's not going to work. So instead, our other solution is going to be negative 5 minus 8.015. So we got negative 13.015 over negative 9.81. And so that is going to be the value that we're actually looking for. And altogether, what time is that going to give us, guys? About 1.33 seconds. Awesome, guys. So that's our first answer. 1.33 seconds. So now we can figure out how far it went. So we know our initial velocity is 20 meters per second. There is no effective acceleration, so this becomes 0. So literally, it's going to have traveled 20 meters per second for 1.33 seconds. So that means it's going to have traveled for a grand total of what? Exactly, Braden. 26.6 meters. Same thing, Raylan. Who needs me to re-explain part of this problem or otherwise? You guys good? Questions? Yeah, for just the straight up distance, yeah, you're just gonna multiply that v sub times time. It's gonna give you how far it went. Okay, so now we're gonna keep all the stuff the same. We're gonna do one more thing. We're gonna introduce the angle to it. And we're gonna figure out the velocity it was actually traveling at initially. Okay? So, now we're gonna figure out what was its initial velocity and what was the angle it was fired off at. This is where we're gonna use our trigonometry terms. First thing we're gonna figure out is the velocity it was going at. Okay? So, think about a triangle. Okay? We're trying to solve for this angle here, angle release, and the overall velocity. And so the reason I finished this box out is notice this creates a right triangle. What was the basic formula for the triangle's sides, guys, if you remember? You can go unmute yourself because it's going to be a lot easier to say it out loud than to go ahead and try to put that up in the chat. I'll be damned. Cassandra was able to just type it out faster. I stand corrected. A squared plus B squared equals C squared. Okay, so in this example, we're trying to solve for C squared. We have A squared, so we're just gonna have 20 times 20 plus B squared, 5 times 5, equals our C squared value. So we're gonna go ahead. So this is going to then go to 5 squared plus 20 squared equals C squared, or 25 plus 400 equals C squared. So then we're going to take the square root of both of these, and that'll give us C. So the square root of 225 is going to be our initial velocity. Oh, sorry, 425. Thank you, Cassie, for giving me the correct answer when I messed that up. Nice. So 20.62, is that what you guys are coming up with? Awesome. So our initial velocity is 20.62 meters per second. Awesome. Now let's figure out the angle, okay? Now, we literally have every single side of this triangle now. Okay? So we can use any of our trigonometry terms of So sine equals the opposite over the hypotenuse. Cosine equals the adjacent over the hypotenuse. And TOA, tangent equals the opposite divided by the adjacent. So you can solve it from any of those directions. So let's go ahead and use the one that we could have done straight off the bat. So we're going to go tangent. Okay? So the tangent of the angle is going to equal the opposite over the adjacent. So tangent angle equals 5, because that's the opposite, over the adjacent, and that's 20. So tangent of the angle is going to equal 0.25. Now, how do you guys do that? Well, turns out we're going to go ahead and do the inverse of the angle. Sorry, of the tangent. Oh boy, I am pushing buttons and buttons aren't toys. Okay, so share my screen. So right here we got that calculator, okay? So you see how we can go ahead and click on trig. Yeah, so we're gonna go second. So now we've got the inverse tan. So we're gonna go 0.25. Okay, I guess it didn't like me touching the point button. Let's try that again. 0.25 trigonometry inverse tangent. And now, because we have this in degrees, it's going to be 14.03 degrees. .03 degrees. Does that make sense what I just did? Now, whenever we're in this class, we're going to do things in degrees. You can do them in radians, but I don't like using radians simply because you guys are much more acquainted with doing things in degrees, not so much in doing things in radians. So, questions? Do we have any questions? Could we go over the calculator steps again? Yeah, no worries, Luke. So let's go back to sharing my screen. Okay, so this right here, notice this calculator. This is just the calculator app. And so you can go into scientific, so clear it out again. Okay, so notice you can actually see what I did last, but we're gonna go ahead because we solved it out to where we only had 0.25. So hence we're gonna go 0.25, and then we're gonna go trigonometry. You click second because notice now it's inverse tangent because we're trying to solve for the angle. We're not trying to figure out what, because if I literally didn't do the inverse, it would just give me the value for the tangent of the angle of 0.25. So we're reverse engineering this. So hence we go inverse tan, and that gives us the 14 degrees. So if I didn't do that and I just put down 0.25, go to trigonometry and click tangent, it's going to give me this incredibly small number because it's figuring that the tangent of 0.25, because that's going to be opposite over adjacent, is going to be very, very small because it turns out that's very slight angle, the adjacent is massive and the opposite is incredibly small. Is that good? Awesome. So, rock and roll. We've gone through and did some fun math today. Or at least I like to think it's fun math. Some of you guys may or may not have nightmares about this, and I'm sorry if that happens. Instead, the goal is to keep going through this, helping you guys make sure you understand how to apply it, so we're going to be able to use it throughout the rest of the class. When in doubt, guys, we need to make sure that we're following our units, and we need to make sure that we're understanding what we're trying to solve for. So the key is to focus on the values being asked for, not to just kind of throw everything at the wall and hope something sticks. Instead, being deliberate of thinking about like, okay, what am I trying to look for, and how can I use the tools that I've been provided to make this work? I don't want you guys to be wasting energy memorizing all these formulas. Instead, I want you guys to think of yourselves as craftsmen, where your goal is to figure out what's the appropriate tool for the job. Because I don't know if you guys have heard the cliche before, but if the only tool you have is a hammer, everything looks like a nail. I want you guys to understand there's a variety of tools, and you have to use the right tool at the right time. And that's the big difference between us and the machines these days, because the machines are really only good at using the one tool they're given. And you guys need to be able to beat the machines. So, questions, comments, concerns? Do you guys want to do like some other type of example? Or you guys want to go ahead and just kind of lecture for a few minutes at the end here? One more. Of what, Zach?
Can we do like another example of the quadratic formula?
Yeah, no worries, man. Okay. Let's go ahead and erase all this beautiful math that I put on the wall. And by beautiful math, we all agree that this is very much so. Oh, yes! Let's have fun. All right. Time for you guys to use some breakout rooms, because up until now, we're going to have done all of this work on Earth, meaning Earth's gravity. But I'm going to divide you guys into groups. And when we're divided into groups, whatever group number you're in, that is going to be the planet that you're going to be on relative. Well, and Earth doesn't count, meaning if you're in group 1, it's Mercury. Group 2, it's Venus. Group 3, it's Mars. Group 4, it's Jupiter. And group 5, it's Saturn, because each of them have a very different gravitational constant. So we're going to solve it for Earth first, and then you guys are going to solve it for one of those other planets, because that's fun. And if you don't like it, you don't like fun. And I feel very comfortable saying that. So let's solve it for Earth first, okay? We're going to go ahead and jump. Or no, we're even jumping, man. We're using like rocket boots. So we're going to go ahead and fire something off the ground at 20 meters per second. Okay? We're starting on the ground. We're going to end on the ground. Make life easy, 0 to 0. And we want to figure out how long was your flight time. Okay? And so on Earth, gravity is 9.81 meters per second. Now, we immediately know, since our x is going to be 0, and we're solving for time, so we're starting and ending at 0, our initial formula is going to then be factored into that 1/2 of negative 9.81, so 4.905, plus 20 meters per second, and then plus 0. And this is all going to equal 0. So from there, we're going to now have negative 20 plus or minus the square root of 20 squared minus 4 times a, which is going to be that negative 4.905 times 0. So that equals 0. Over 2 times 4.905. So now we're going to have effectively option A, which is 20 squared, 400, square root of that, back to 20. So if we take and add 20 to negative 20, we're going to have 0. Congratulations, we started at the ground. The other option is going to be, we're going to have negative 40 over 9.81, and that's going to be our time. This is also still a negative number here. So that means our total time value is going to be about just a little over 4 seconds. What do you guys come up with for that? 4.07. Thank you, Luke. Sounds about right to me. Anyone disagree with Luke's number? All right. So on Earth, you would go and be in the air for 40.7 seconds. Or sorry, 4.07 seconds. Now it's time to figure out what that's going to mean on some other planets. So you guys are about to all go into breakout rooms. Remember again, if you're in breakout room 1, you guys are going to be doing this on Mercury. So that means your acceleration is going to be different. Now, that's acceleration on Earth. So if you can only find the example online that says Mercury's gravitational force is just a quarter of Earth's, well, you're just going to take that and multiply that by 0.25. Same thing, group 2, Venus, group 3, Mars, group 4, Jupiter, group 5, Saturn. Questions?
Can you write that in the chat? Like what group's what? Sorry.
Cool. You guys got that? You're going to be randomly put into those groups, unmute yourselves, and you should be able to chat also in your group, and then work on setting this math up on your own and going through it. So here we go in just a moment, guys. I'm going to give you guys 5-6 minutes as a group to come up with your answer. You're going to have to figure out what the gravitational constant is. Use the power of the internet for that. Then you're going to go ahead and set up your formula accordingly to whatever that new acceleration constant is, because your velocity is going to be the same. And from there, you're going to go ahead and run through that quadratic equation, and then you're going to come back and tell us how long you'd be in the air for. So have fun, guys. As we're getting closer to the end here, I want you guys to go ahead and just put up in the chat effectively the planet that you guys had, and then what would be your flight time. What would be your flight time? Okay, well, Saturn is a fascinating one. Okay, so I can definitely tell you guys, looking at your numbers, the group that had Mars and the group that had Jupiter are definitely correct. because the gravitational constants, Mars is much lower than that on Earth, and then the gravitational constant on both Jupiter and Saturn are much higher than they are on Earth. So both Saturn and Jupiter, you should have jumped less. But on Mercury, because the gravity is less than that on the Earth, you should have jumped a bit higher. And then the Venus group, oh, there we go. Yeah, the 10.49. Thank you, Catherine. So yeah, good job, guys. See, that's what's fascinating when you look at gravitational constants, where, think about it, your abilities as far as your athleticism, how fast you can run, how high you can jump, is heavily influenced by gravity. So if all of a sudden you're on a planet undergoing twice the gravitational force, or with Jupiter, it ends up being pretty close to 3 times Earth's gravity, you are not going to be able to really get that high off the ground. Meanwhile, if you could get to play sports on Mars or the moon, any of us could dunk. In fact, a number of us would literally be able to headbutt the top of the backboard. Not that you'd want to do that because that doesn't sound safe or smart, but because of the differences thanks to those forces, or the gravitational force you're encountering. Does that make sense to you guys? You guys kind of able to kind of hash it out together and it helped you understand a little bit better? Awesome, guys. Well, that's all we're going to go ahead and go through today. When we meet up on Thursday, we are going to go ahead and start lecturing over Chapter 3 some, and we're going to keep working our way through problems. So, you know, shoot me, make this kind of your guys, aside from doing your chapter homework and making sure you're taking the quiz, and then taking those quizzes in the groups that you guys are doing your movements with, and make sure everybody's emailed me those groups. I think most all groups have. I'm still waiting on 1 or 2. Yes, we can go ahead and talk through Lab 1. Lab 1 is just going to be basic anthropometrics. So you're literally just going to be measuring limb lengths. And so, but yeah, we can go ahead and talk through that then, along with, yeah, I want you guys to think up some problems you want us to go ahead and work our way through. Now, obviously, we're always going to have more. Okay, so real fast, guys, one person from each group, just go ahead and say what your movement is. We've got 1 student that's looking for a group. So, 1 student is looking for a group. So whatever group looks interesting to you, Lucas, feel free to go ahead and send a private message real fast to that student that just put up the information here, and then guys exchange contact information and then email me that updated list, okay?